now I did. All right, so first of all, there's a cute little picture of me over here to the left, and I'm frying some eggs and bacon. Could someone please raise your hand or comment in the chat? What type of heat transfer am I using to cook those eggs and bacon? Oh, Genesis, that was quick. Yes, what do you think?
Radiation.
Okay, why do you think I'm using radiation?
Because you're using heat.
Okay, but remember convection and conduction, heat through touch, also are dealing with heat. So remember, our keywords for radiation are rays or waves. So do we see sun rays or light rays or microwaves here in this picture?
No.
No. So what do you think another good guess might be?
Conduction, because when you cut it off, then it cools down.
Okay. Yes. So absolutely, we are cooking those eggs and bacon, and thank you to Fumi and Cullen and Mackenzie. You answered correctly in the chat. We are cooking those eggs and bacon using conduction. The eggs are touching the pan, which is touching the burner on the stove, to cook through direct touch. The heat is being transferred through direct touch. Now, in this picture, they're all up in the air, so I thought I was going to confuse people, and you were going to say convection because they're in the air. No, I'm just being fancy like a little chef. Yes, Nellie, would you like to add something? Nellie?
I think it would be conduction because the burner is touching the bottom of the pan when the bottom of the pan is going to the top of the pan where the eggs and bacon are, so then it heats up the bottom, and when you flip it, it heats up the top.
Yes, that's exactly right. So everything is touching. So that's how we know conduction, conduction, that's heat being transferred through direct touch. Excellent job. All right. So on Thursday and Friday, I had you guys submit some pictures to me about heat being transferred around your house. You were supposed to look for an example of convection, conduction, and radiation. And you were supposed to label those pictures and show me how the heat was being transferred. Some people who are in this room right now did not submit an assignment, so this may be a good idea for you to kind of get some ideas, maybe get your wheels turning for some ways that you can find these processes occurring around your house. Now remember, in order to get full credit, you had to take a picture, you had to annotate or write on the picture, and you had to give me some arrows to show where the heat was transferring to and from. So probably one of my favorites was this one here in the middle, because everything was color-coded. We had heat waves that were illustrated here. For radiation, we've got our waves. It says you can feel the thermal energy from the sides, heat waves. For radiation, love that. They included our keywords there. Also, they killed two birds with one stone here. They did convection and radiation all in the same image. It says that thermal energy is rising up in the air and you can feel it. And that's absolutely correct. So as the fire is burning, it's warming the air around it. And we know that warm air rises. And as it gets further away from its heat source, it begins to cool down, condense, and then that's what causes the air to fall. So yes, convection is also occurring here. So this student got full credit for both convection and radiation because the process was explained and identified in the photo. Here we have the cold air is denser than the warm air coming out of the air conditioner. The cold air is denser. We have radiation. Heat is being transferred to this person's hands without them touching the fire, without them touching the electric heat. They can feel the radiation coming out from the heater. And then this one here is a student from this class, and they have an example of a tea kettle. It says inside the kettle, the molecules are moving and spreading around, and what happens is the molecule starts spreading around so fast and vibrating so fast that they eventually change from a liquid to a gas, and they begin to escape the teapot as steam from the kettle. Now, convection is occurring in the teapot because, remember, the water molecules that are closest to the burner are heating up and they're moving more rapidly. So as they become less dense, they rise because hot water and hot air rises. And then as it gets further away from its heat source, the molecules begin to slow down, they cool down, they start to condense, and they fall. But as they get closer to the burner, they start to move more rapidly, they start to spread out quite a bit, they become less dense, so they begin to rise, and then they clump together as they cool down away from the heat source, and that cycle, that convection current, continues around and around and around. This would also be an example of conduction because the kettle is on the eye of the stove. Excellent job. All right, so here we've got a warm little furry little cat who's curled up in a chair. And this student said that the chair is warming up because of the warmth of the cat. So yes, all of us right now, whether we realize it or not, we are transferring heat energy either to the air around us or maybe to the chair that we're sitting on or the bed that we're laying on, which we shouldn't be laying in bed, or maybe the floor that we're sitting on, but we are transferring our body heat to whatever it is that our body is touching. So that's an excellent job, just like this cat. We have convection is happening here because the warm air is being sucked into the air return, and then the cool air is going to be sent out of the vent. So that's excellent. This student really impressed me because there was not a microwave around, not a stove. They couldn't use the normal things that we were talking about in our lesson. So she used the tools that were around her, and she held onto the glue stick, and she said, my body heat is being transferred to the glue stick. So the glue stick will get warmer as the heat is being transferred to it. Excellent job. I also loved this image. I cannot remember who did this one, but it's great. I love how the words are color-coded. We have cold in blue, hot is in red to indicate the temperature or the amount of movement that the molecules are having. Excellent job. It said, and then we have our arrow. The heat is going from the hot finger to the cold ice. Heat is being transferred into the glass by my finger. Excellent job. And then my last page of some of the best scavenger hunt entries, and I know that some of these entries are from some of the people who are in this class, so excellent job. We have radiation is used when the heat from the microwave travels and warms up the food. Excellent job, excellent description. Radiation is occurring inside the microwave. Thank you for labeling that. This student, again, radiation in the microwave heats up the mac and cheese. Very clever, added those electromagnetic waves in their annotation on their picture. Great job. That made me very proud. We have, again, someone using the best materials they had around them. Conduction happens when I put my body heat on the slime. It gets warmer because the heat is transferred from our body to whatever it is we're touching. Last two examples, we have convection here occurring. Cool air comes out of the vents. It warms up, goes back into the vent, comes out cool. The cycle continues on and on. We know it's convection because it is air or fluids moving in a cycle or a current to cool one another down. And the last one, this was really cool. This student used the thermal imaging filter on their iPad because, you know, we're working with thermal energy anyways. They said radiation from the sun heats up this black roof. They went one step further and even said heat radiation from the sun happens here, but they remembered this from the very beginning of our heat transfer unit. White objects aren't good absorbers, but are good reflectors of heat. So this student is absolutely correct. If we were to get a ladder and climb up on top of this roof, those black shingles would be much hotter than that white vent that is on the top of our roofs, because white reflects heat while black colors absorb, or darker colors absorb the heat, really soak it up. All right, so excellent job. I was very impressed. Many of you who are in this class were featured. Just because you were not featured did not mean that you did not have an awesome assignment. It was honestly just the couple. I kind of went through and said who had 100, and I looked to make sure they had all the pieces of the puzzle, but I definitely missed some of your examples just because I didn't have enough room for everybody's. But please check your echo feedback because I was very impressed with a lot of what some of you did. For this assignment, Jamari, I did not get your Friday assignment. No. Never mind, not you. It's your brother. I'll talk to him in a little bit. But some of you, if you did not submit your assignment, I just gave you the score. Genesis, I did not get yours on Friday. So if you go back and you submit yours from Friday, then your grade, of course, for this assignment will increase. Trying to look very quickly without taking much of our time. Jaquel, I did not get your assignment from Friday for heat transfer. And I believe that is all for this class. You guys probably do the best out of any of the classes for work completion. And Alicia, is Alicia in here? No, she's in the other class. Yeah, never mind. Okay. All right. So another thing we talked about was your knows and need to knows for your assignment for the animal shelter. Now, keep in mind we are. Let me check the chat. See, I've got 2 things. Oh yeah. All right. So we are not actually building an animal shelter. If you want to go above and beyond and your parents want to build an animal shelter using your scientific concepts, then absolutely, more power to you. I'll give you some extra credit or something to commend your efforts, but that is not the purpose of our animal shelter project. So by Friday, next Friday, you all will have designed an animal shelter for either a dog or a cat that will keep the dog or cat warm in the winter or cool in the summer. You will have a blueprint, so you're going to have a sketch of your design, and you're going to have a list of materials and why you've chosen those materials. So you're going to use your knowledge from your assignment yesterday about conductors and insulators. What type of materials would be good to keep heat in its place? So I want everybody to stop right now, and for like 2 minutes, I want you to think about your assignment from yesterday, the pear deck that you all did, and it told you what conductors were, what insulators were, and then it gave you some examples. I want you to think about those things. What type of materials would be good to think about starting to design your animal shelter with? Okay, Samara's raised her hand. She'd like to share. So just a few more minutes. I'm going to give you guys a few more minutes to think. All right. So what do you think, Samira, what do you think a good material would be to build your animal shelter out of?
I think metal.
Okay. Why do you think metal would be a good one?
Because it transfers heat through it.
Okay, it transfers heat through it. So are you trying to keep the animal warm in the winter or cool in the summer?
Warm in the winter.
Okay, you want to keep the animal warm in the winter. So you're proposing that we could build an animal shelter out of metal because it transfers heat easily. What do you guys think about Samira's idea of building the shelter out of metal to keep a cat or dog warm in the winter? Okay, Cullen, thank you for raising your hand. What do you think about that?
I disagree with Samira because if it was in the summertime, the dog or the cat would be extra hot. And depending on of how much fur it would have, it would either get overheated and die supposedly, or wouldn't.
Okay,
It
so,
would just get heat stroke.
okay, well, your thought process is absolutely correct, but she did say that she wanted to do it out of metal for the winter. So do you think metal for the winter would be a good idea?
Yeah, but the question is where would you find all the metal?
Okay. So Colin thinks it could be a good idea, but his question is where would we find the metal? All right, I need someone else. Give me some feedback. What do you think about Samira's idea? Oh, Mackenzie. Do you want to type what you were going to say?
I accidentally put the hand, but I was thinking about another material I could use.
Okay, do you want to share your material?
Yeah, I think wood would be a good idea to build a shelter out of because wood is an insulator and the heat would stay inside of it if we made a shelter out of it.
Okay, excellent job. So I like what you said. Wood is an insulator, so the heat would stay inside of it. That is actually the best way that I like to tell my students to remember. Insulators keeps the heat in its place. So if you have an insulator outside of something warm, it's going to help it keep it warm. I have coffee in here. This is kind of like a foam container. It's polystyrene foam, so it's keeping my coffee nice and warm as we are talking through our lesson. That way it doesn't get cold. However, if I were to put my coffee, well, my glass beaker is not around here. If I were to put it into a glass container, it would cool down much quicker. Or if I were to use this thin plastic, even though plastic is an insulator, when it's really thin like this, it doesn't have much insulative properties. However, so that is a great idea, Mackenzie. But I do want to go back and revisit Samira's idea. And in order to help you all better understand, I'm actually going to roll my cart over here to my whiteboard. And I would like for you guys to just bear with me as I very terribly try to draw something. Okay, so we're thinking a metal shelter. Usually metals are silver or black. So I'm gonna just draw me a metal shelter. This is metal, right? Okay. So we found some metal from somewhere and we were able to build a cat shelter out of metal. Okay, and I'm assuming that we're probably going to have it on the ground, so I draw some grass there. Now, I'm going to draw my cute little kitty cat. Okay, and its body and its tail. Okay, there's my cute little cat. Sorry if you guys can't really see it. My brown marker's almost dried up. Okay, so let's think. If it is cool in the winter, these are snowflakes. This is telling us that it's cold. So if we have snowflakes outside, what does that tell us the temperature is at least? What's the golden temperature for snow? Not 50 degrees, lower. Temperature has to be lower. No, it's higher than 20. If it's 20 degrees, it's definitely snowing. Close, Boomy's close. So, if it's snowing, that means that the temperature is at least freezing. Freezing is 32 degrees Fahrenheit. So right now, our temperature is less than 32 degrees Fahrenheit because we have snow. So it could be 20 degrees. It could be 31 degrees. It could be 32 degrees. But right now it is snowing, so we know that it's super cold outside. Now, we know from our picture earlier that cats are warm. And let's just say cat's body temperature is roughly the same as a human's body temperature. What is our body temperature? What's a normal temperature for a person? Anybody know? Warmer than 70 degrees. 70 degrees is usually the temperature of like inside of a house. Okay, 98 is, yes. So the human body is usually 98.7 degrees, okay? So here we have a cat, which is 98.7 degrees. We're giving it the exact human body temperature. Now, Samira, everybody look at Samira's screen because she has my lovely anchor chart for how heat moves. Samira, scooch over to the side so we can see your screen. All right, so how heat moves. Heat moves from hot to cold. So which direction is the heat easily going to transfer when we are in this metal shelter? Haley Clemenet, is the heat going to transfer from the cat to outside or from the outside to the cat?
From the outside to the cat.
So you're saying the heat is going to transfer from the cold to the hot?
No, the opposite of what I said.
Yes. Okay. And I knew you knew that, so that's why I restated what you said. So yes, the cat's body heat is going to try to warm up the air around it because that's the way heat flows. We can't stop that. That's just a fundamental law of nature. We cannot stop that. If something's warmer than the air around it, then heat is naturally going to transfer. So the body temperature from the cat is going to easily transfer through this metal if we create a shelter out of metal with no insulator around it. So a metal shelter probably wouldn't be the best idea, even if there was a door, because the walls and everything is made out of a conductor that's going to allow the heat to easily pass through it. Because heat transfers from hot to cold. Now, if we wanted to get fancy, let me find some other markers. If we wanted to get fancy and maybe stuff some styrofoam or something around this metal, so we would have an insulator here, keep the heat in its place, and then went around again with something like Mackenzie said, like another wood insulator that's also going to help to deflect some of the water, like when it rains and stuff. So we put wood here. We have double insulators. So now this could be ideal situation because we're going to use the idea that Samira was thinking. Well, a conductor is going to help transfer heat, but if the cat is in the metal and it's transferring heat and the heat hits the insulator and it bounces back, then what's going to happen is the cat's body heat is actually going to heat the area around it to the same temperature that the cat is, because the heat is radiating off the cat to the metal, and the metal is going to send it back because once it hits the insulator, it can't go anywhere. And especially when you have your double insulator. So I want you guys to keep that in mind. Does that make sense? Or did I just like blow your brains with all that? Yeah. Maybe. I don't know. Yeah, we know. Okay, it makes sense. Thank you, Colin. At least I know I have about 4 people in science who are paying very close attention to me. I love it. I would love it if the other 10 were also paying as close attention. Thank you, Mackenzie. All right. So I hope you guys store that in your brain because you are going to you guys are gonna start designing your shelter starting tomorrow. But today you guys have an assignment, so I'm gonna go ahead and get that out to you and share the expectations for that so that you can get started, because my discussion lasted a little bit longer than I had anticipated it to, but you guys made me really excited. So, don't peek at what yours is for tomorrow. Okay, get to tell me what I'm doing tomorrow. All right, I'm gonna log into Echo, just like you guys do. Actually, I'm gonna log in as a student so I can kind of see what you guys see. Okay, all right, so I'm gonna go to science because we're in science now. And this is your assignment for today. There is an insulators and conductors lab. I encourage you all to watch that. It's only a 2-minute video and it shows you how slow or fast insulators and conductors can transfer heat. But then this is your assignment. I've given you the instructions twice because for some reason you all are not reading the instructions at all. You also have 2 attempts on this assignment. So if the first time you bomb it, you get 1 more try, and that is absolutely it. If you do a fantastic job the first time, don't use the second attempt. So it says to read and download the passage attached to this assignment. If needed, follow along as the passage is read aloud. This is blue and underlined, so what does that tell us, Jaquel?
You need to press that.
Yes, so if you want to listen to the passage being read aloud, you want to follow along with me, you're going to click that link because when it's blue and underlined, that tells us that it is a link. And you guys can follow along with some little tunes and me as I read this passage to you. I'm simply just scrolling down the passage, reading, if you want to have the passage read to you. And then you're going to answer the questions about the passage. Then you'll submit your work. My suggestion is to open the passage, and it's probably going to open up in the same window as your Echo does. But my suggestion is to have 2 separate windows and then to do, sorry. It's a little different from my, when I do it on my computer, it's a little different from the iPad. But if I were you, what I would do is split the screen, have the passage on one side, have my assignment on the other, which I can't get to because gotta love technology. Here we go. All right. So this is what I would do. I would have my screen split so that one thing is on one side, one is on the other. And then I'm going to start my questions. And then my questions are going to be here and my passage is here so that I can go back and I can use the text to help me answer the questions. Okay, now sometimes the passage is written right there for you.